Good afternoon, everyone, and thank you for attending our EC Motors for Commercial Refrigeration DOE 2017 Compliance webinar. My name is Keith Rujo, Marketing Manager here at EPIC. Before we get started, I just want to let you know that you all will be muted during this presentation. If you have any questions as we move along, please enter them into the questions panel located in the webinar control panel. We will try to get to all the questions at the end of the presentation, but if we don't have time, we will be sure to reply back to you all by email. Also, we'll be recording this webinar. We'll be posting both the recording and the slides on our website and YouTube channel. Our presenter today is Simon Gidney, President of EC Fans and Drives. Simon, an attorney by background and training, is a successful business leader with experience in a wide section of industries across many countries. He has obtained a law degree with the University of Bristol, England, and an MBA from the University of Warwick, England. He has spent many years working in the corporate restructuring and turnaround operations in the UK and in the United States. He has hands-on experience in many different industry sectors and international markets, with particular experience in building international sales and distribution networks. So without further ado, I'll pass it over to Simon.
Thank you, Keith. Welcome, ladies and gentlemen, to this webinar, which will be looking at DOE 2017 compliance in the commercial refrigeration sector. I'd like to say, first of all, that I hope all of you have had an excellent Christmas and looking forward to a successful 2017. Right, so what we want to cover at this today, this webinar, is we want to look briefly at the Department of Energy regulations for 2017 as they affect efficiency requirements for manufacturers of commercial refrigeration equipment. We're going to look briefly at why we would believe the best solution for that are electronically commutated motors. And then we're going to give you an overview of the product range that EC Fans and Drives have developed in the EC motor sector, which we believe give a flexible product range which should give assistance to any commercial refrigeration OEM who is either struggling with or looking to tweak their designs in order to meet the 2017 regulations. As all of you will know already without me having to mention it, is the Department of Energy has for some time singled out the commercial refrigeration market as a specific target for demanding increased efficiency. They passed regulations back in 2014 which mandated a significant reduction in the amount of energy consumed by commercial refrigeration units. And they are now introducing, effective from March onwards of 2017, a new set of mandated efficiency requirements which will see once again a significant mandated requirement to increase the efficiency of commercial refrigeration equipment. A very brief overview of the regulations. You can see there that the additional mandated increases in efficiency are very significant, ranging from anywhere from 30% to 60% in allowed energy consumption, depending on what type of product it is. Different regulations for walk-in coolers and freezers, and new mandated requirements coming for automatic commercial ice makers. So it's clearly an extremely important and an extremely challenging issue that a commercial refrigeration OEM has on their radar. The United States Department of Energy is a cabinet-level department within the United States government, and so when these regulations are passed, they're not optional, they are mandatory. We have had experience over the last 4 to 5 years with working with US and European OEMs in this sector, helping them to meet the DOE 2014 efficiency requirements, and so we have a lot of experience in this area. I think it's probably safe to say that there were a number of OEMs who were able to meet the 2014 regulations while still being able to use what I would refer to as old-style technology, such as shaded pole motors and permanent split capacitor motors. They were able to use those type of motors and still, in some cases, managed to come within the DOE 2014 efficiency requirements. However, as we shall see in the next few slides, I do not think that that's going to be possible for the 2017 increased efficiency requirements. Why then would we be designing our product range around electronically commutated motors? EC, that is the EC, that is EC fans and drives. It's our core product area, our core expertise. All of our products are electronically commutated EC motors. The principal difference between an EC motor and a typical old technology shaded pole or permanent split capacitor is that the efficiency level of a shaded pole motor or a permanent split capacitor motor traditionally would run somewhere around 15 to 20%. What that means is that 85% of the input power that is coming into the motor from the external power source is actually used to run the motor itself. That means that there is only around 15% of that input power left to actually run whatever application the motor is being installed to run. An electronically commutated motor, an EC motor, however, is far more efficient. The efficiency level of an EC motor is likely to be up in excess of 60%. So you can see that there is an extremely large increase in the inherent efficiency of an EC motor over a shaded pole or a permanent split capacitor motor. You then extrapolate that out into an average supermarket where you're likely to have 400 to 500 motors running during the day, then the increased savings in efficiency are very, very significant. The principal reason why an EC motor is far more efficient is that a shaded pole or a permanent split capacitor motor will have mechanical brushes. In an EC motor, however, everything is done through the use of onboard electronics, which sense the rotor position of the motor and switch the supply accordingly, rather than in an old technology motor creating a magnetic field with mechanical brushes. The other interesting byproduct of the design is that an EC motor will generate far less internal heat than a shaded pole or a permanent split capacitor motor. The rotating of those brushes in an old technology motor creates a lot of heat, which, apart from raising the actual internal operating temperature of the motor itself, it also means that the life expectancy of a shaded pole or permanent split capacitor motor is far less than an EC motor. We therefore have, as I mentioned earlier, we have developed a range of products all centered around our expertise in EC technology. And we believe with the 4 products that I'm going to run through now, we believe that we are able to present a flexible and broad product range of options which will allow commercial refrigeration OEMs a number of different ways to meet the DOE 2017 increased efficiency requirements suitable across a range of different size applications. The 4 products are the economy motor. We call that our entry-level single-speed EC motor. We have an EC Plus motor, which is a premium level, 3-speed, programmable, and bidirectional EC motor. Our EXI 50 motor, single direction, extremely slim profile, and then we have a range of EC axial fans. So starting with the economy motor, the economy motor is a highly efficient single-speed EC motor. It has an operating range anywhere between 1 watt to 30 watts input. It has a soft start function, and the is available with a speed which can be pre-selected anywhere between 600 to 2,100 RPM. The soft start function is important to mention because what that means is that when power is put to the motor, although it may seem imperceptible in real time, it actually ramps up to the desired operating speed rather than just going from 0 to, say, 1,700 RPM. Other motors on the market without that soft start functionality, when they go straight to the operating speed, it can cause a power surge, which in some cases can cause other electronic systems in the manufacturer's case to blow. The EC motor is available in either 120 volt format, 230 volt format, global voltage, which will be anywhere from 85 volts up to 265 volts, and it is also available in a 24 volt DC format. We have also in development a 2-speed version of the motor. That will be launched at the AHR show in Las Vegas at the end of January. As I've said, the power range for the economy is from 1 watt to 30 watts. The speed range is anywhere from 600 RPM to 2100 RPM. Efficiency is as good as anything else on the market, in excess of 60%. The EC Plus motor is a premium, highly equipped EC motor. It has additional functionality, and as a result of the additional functionality, it would be a higher price motor than the economy motor. The EC Plus has 3 preset speeds. It has a reverse functionality, so it can be set to time reverse. You can change the direction of the motor. Its operating range is anywhere between 1 watt and 22 watts input power. Now, over the last 4 years, we've been extremely successful in the United States and in Europe with the EC motor. It has been in constant use now with a number of leading commercial refrigeration and vending machine manufacturers in the United States and in Europe. We have also, through our aftermarket distributor, established a very significant presence with the EC Plus in the commercial refrigeration aftermarket. It's effectively become the retrofit motor of choice. So a very successful track record in the marketplace. The EC Plus can be supplied with a programmer that will allow you to change the speeds that have been selected, and it will allow you to change the direction of rotation. Those changes can be made via a laptop. We found that has been most useful in early development stages where engineers perhaps have not quite settled on the combination of motor speed and blade diameter and pitch. And so the flexibility afforded by the EC Plus has allowed them they can run an application at a particular speed. If they're not happy with the airflow or the noise levels, they can then, through the programmer, change the speed and run a whole series of different iterations with different speeds, different fan blade sizes. As mentioned before, the power range on the EC Plus would be 1 watt to 22 watts input power. It's the only commercial refrigeration motor available, as far as I'm aware, with 3 pre-selectable speeds, anywhere between 300 RPM to 2,500 RPM. It has the same soft start functionality that I talked about in connection with the economy motor, and once again, the efficiency of the EC Plus motor is as good as any commercial refrigeration motor out there in the marketplace at the moment, in excess of 60%. Time reverse functionality is also available, and we can supply the motor in an ATEX, with an ATEX compliance certificate. Just as a side note on ATEX, which is important as more manufacturers move to the use of hydrocarbons as the refrigerant, in discussions with UL over the last 12 months, UL are of the opinion that due to the design and construction of these EC motors, that they do not technically need an additional ATEX certification, and we are able to provide copies of written confirmation from UL to that effect. However, if you feel that you do, in spite of that, you do need ATEX compliance and certification, that is not a difficult problem for us to address. We can supply that. Moving on to the EXRI 50 motor. The EXRI 50 motor is again a single-speed motor. The exciting thing about the EXRI 50 is that it is designed and built with an integrated fan blade. The fan blade is actually molded over the rotor cup, so you do not buy a separate fan blade when you buy an EXRI 50, as you would with our EC Plus motor, our economy motor, or any other EC motor out there in the marketplace that you would be considering. The thought process behind the EXRI 50 was based on the experience we've gained over the last several years in the commercial refrigeration market. We've developed a feel for what are the most popular fan blade diameters and pitches, and what are the most popular speeds that OEMs have required from us. So the EXRI 50 motor has been designed with that in mind. It is not able to address every application out there, but it is targeted at probably 75 to 80% of applications out there. The fact that the fan blade is an integrated part of the motor design means that the profile of the unit as a whole is extremely slim. If you buy a conventional commercial refrigeration motor, such as our EC Plus or our economy motor or another manufacturer's motor, you would then buy a fan blade, or the motor would come with a fan blade which is then fitted to the shaft protruding from the motor. If you purchase an EXRI 50, the blade is already integrated in the design, so the width of the unit as a whole is considerably reduced, which is very attractive if you're working on an application where you've got reduced physical space. The other significant benefit of the EXRI 50 motor is that the design of the motor itself is extremely compact, which means that the motor itself is a smaller obstacle to airflow than a conventional commercial refrigeration motor would be. Because of that, the motor itself reduces the air over motor resistance, so that more airflow is produced and is available than would be produced by a motor of a similar size with a conventional design. At the moment, the EXRI 50 is available with 3 different fan blade sizes: 154 millimeter, 172 millimeter, or 200 millimeter. So available basically in 6-inch, 7-inch, or 8-inch formats. It can also be supplied with a fan ring fitted, as shown in this slide here, or we can supply the motor without a fan ring. Sorry, with a fan ring fitted, or we can supply it without a fan ring. The EXRI 50 motor is global voltage, so you don't need one unit for 120 volts and another unit for 230 volts, so one SKU instead of 2. It can run comfortably anywhere between 85 volts to 265 volts. We have also developed a low voltage DC version, so it is available in a 24 volt DC format. If you're looking at, some manufacturers are now starting to look at DC motors, and certainly the EXRI 50 is available in a 24 volt DC format. The other factor with the EXRI 50 is that it's single speed, and those speeds were selected by us, again based on our knowledge of the industry and the most common motor speed and fan blade size combinations. So the 6-inch 144 millimeter version comes with a speed preset at either 1300, 1600, 1850, or 2100 RPM. The efficiency is at the same level as the EC Plus and the economy motor, once again comfortably in excess of 60%. The final product category in our range are a range of EC axial fans. So this is an extensive range of high-quality axial fans. These would be a replacement for an existing AC axial fan that runs off either 120 volt or 230 volt input power. These fans are global voltage, so again, one SKU will run on either 120 or 230 volt. The fans, as with the EXR50, can run anywhere between 85 volts AC and 265 volts AC. Also particularly useful if you are selling your product into an indigenous environment where the voltage fluctuates a little bit. These fans are obviously not thrown off by that due to the broad range of voltage at which they can operate. The principal attraction of these fans is that in general they would consume half as much electricity as a conventional AC fan of the same frame size would consume, with absolutely no drop-off whatsoever in airflow. We have been selling these fans very successfully. We have a lot of very satisfied customers. They provide an extremely attractive, energy-efficient alternative to an AC axial fan. These fans are available in frame sizes that run from 60 millimeter by 60 millimeter square up to the largest, which is 172 millimeters by 151. Each fan is available with 3 different sizes: thickness, 25 millimeter, 38 millimeter, or 51 millimeter. Each frame size, we will have 3 fans in that frame size: a low speed, a medium speed, and a high speed. And taken as a whole, the airflows available across this range of fans run from 11 CFM up to 258 CFM. Once again, these fans' efficiency is up at the 65% level. Standard IP rating is IP55, although we have just developed a version of this, the 120 millimeter unit, which is IP67. We recently showed that fan at the Chillventa exhibition in Nuremberg in October, running in a case underwater, and we will be repeating that demonstration on our booth at the AHR show in Las Vegas at the end of January 2017. These fans can also be supplied with a 0 to 10 volts or PWM variable speed control. This panel shows gives you an idea of some of the customers that we have been working with over the last several years. Essentially, in summary, for an OEM who's looking at the challenge of meeting the DOE 2017 efficiency mandates, it is a very significant reduction in the power consumed by commercial refrigeration units that are in the marketplace prior to the implementation of the 2017 mandates. As I said before, when the 2014 regulations came in, some manufacturers were able to squeeze efficiency savings out of their cases without having to move away from shaded pole or permanent split capacitor motors. However, the difference this time round is that because of the additional reduction that is required in power consumption, pretty much the only place that an OEM can go to find that additional saving in power consumption are the motors in the case. Effectively, you are just going to find it extremely difficult, if not impossible, to get there using shaded pole or permanent split capacitor motors. There really is no drop-in replacement solution for that old AC technology other than an EC motor. There are people at the moment looking at possibly bringing back synchronous motors. Synchronous motor technology has been around for a long, long time. In our view, a synchronous motor can be useful within a very narrow operating window, given the very limited speeds at which it can operate. But they certainly wouldn't give you anything like the flexibility that an EC motor solution would give you. In our view, given the 4 product categories that we've been through in this webinar, we do have a very, very flexible product offering, which would allow you to choose the particular product that suits your requirements. We also have an extremely experienced and very responsive engineering team led by Martin Powell, who's based in the United Kingdom. We are very keen to work with the engineering teams at our customers. We like to get to work with them as early as we possibly can. We're very happy to assist with testing, with sampling, with tweaking solutions. We're happy to look at the existing configuration you have and come back to you with our recommendations as to which of our products we feel could increase the efficiency of that configuration and make other suggestions that we feel may assist. We really can't get involved too early as far as we're concerned. We're very responsive, very proactive, and would welcome the opportunity to sit down with any of your engineering teams to talk about what they need to do, what they need to achieve to meet these DOE 2017 regulations. We've worked successfully, as I said before, over the last 4 or 5 years with major OEMs, and we have helped them to look at various iterations to come up with a combination of motor, speed, fan blade diameter, fan blade pitch, voltage options, which have been able to produce a tailored solution. And you know, we're very, very keen to work with you on that basis. I think basically that's probably completed you know, the presentation that I wanted to make. I'll hand over momentarily to Keith.
Thank you, Simon. While Simon reviews some of the questions that came over, I just wanted to let some of you know of some of the other products that we offer here at Epic. Custom battery packs, our Flex and Rigid-Flex circuit boards, high reliability user interfaces, energy efficient motors and fans, as Simon just reviewed, our cable assemblies, and also our core product is printed circuit boards. Next slide, please. Along with our products, we have design and technical support set up all over the country to go along with each of our product. Our battery pack and power management is done out of our center in Denver, Colorado. Our user interfaces are managed out of Largo, Florida. Fans and motors, both here in New Bedford, Mass, as well as in Wales and UK. Our printed circuit boards are here in New Bedford, Mass, as well as Shenzhen, China. Flex and Rigid-Flex circuits are out of Toronto, Canada, and our cable assemblies are also manufactured in Largo, Florida. Next slide, please.
Okay, thanks, Keith. Just looking through, I have 2 or 3 questions that have come through. The first question is, could I clarify how the speeds are selected on the EC Plus motor? Certainly, the EC Plus motor is available with a programmer that is connected to a laptop and connected to the motor. That allows the 3 preset speeds to be changed to any combination of speeds within the range of speeds, and also you can change the direction of rotation. Now, just to clarify, because I think this is what the question is getting at, it is not designed to actually change the speed of the motor while the motor is in operation. Out of all the customers we have, only one actually does that, and they do that by incorporating a external switch. They have an external 4-position switch, 0, 1, 2, 3, where 0 switches the motor off, and then 1, 2, and 3 will click the motor to the 3 speeds that are pre-selected on that motor. So that's the only customer we have who actually needs to change the speeds in operation. You can't do that through the motor alone, but we worked with them to select an external 4-position switch, which then allows them to change that. As far as changing the speeds on the EC Plus is concerned, we have found in the vast majority of cases that the 3-speed availability is used really only in the development stage, because it is very useful to be able to run different tests in the lab where you try the meter at 1 speed, and then rather than having to order 30 samples from a manufacturer with different speeds, you can simply connect the laptop, change the speed of the motor, run the test again, and look at the results. So it's been very much used as a development tool. It's not been used to change the speed of the motor in operation, apart from that one case where they fitted an external switch. So I hope we clarified that. Next question, where would you use an EXI 50 motor as opposed to the economy motor? That's a good question, as both motors are single speed, both motors have the same efficiency level, and obviously there are a number of areas of crossover where you could use either the economy motor or the EXI 50 motor. Probably two answers to that question. The first is the EXI 50 motor would definitely be the motor to choose if you are working in an application where the physical space is limited. Because the blade, the fan blade on the EXI 50 motor is integrated in the motor itself, and rather than being bought separately and attached to the motor shaft, which is the case with the economy, the EXI 50 profile is very slim, much slimmer than an economy motor, slimmer than any other commercial refrigeration motor out there available in the marketplace today. So that would be the first situation where you would look to an EXI 50 motor as opposed to an economy if you're working within a tight physical space. The second is that particularly if, I mean, either of these motors can go in an evaporator or in a condenser, but sometimes with a condenser motor there's a lot of stuff down there and liquid spills, etc., and often manufacturers prefer to select their own fan blade or a specific fan blade diameter or pitch. Obviously you can't do that with the EXI 50. The EXI 50 comes with the fan blade. So if you are in an application where you need to specify specific fan blade material or diameter or pitch, then the economy motor would be the choice, because you can fit any fan blade to that motor providing that it still remains within the motor's 30-watt maximum input capacity. Next question I have here, and I've got time to deal with one more, is are any of the fans or motors shown in the presentation available with a variable speed option? Right, running through the 4 product areas, the economy motor in 120 volt format, 230 volt format, or global voltage format, that's 85 volts at 265, is not available with a variable speed functionality. If you purchase the economy motor, however, in 24 volt DC format, it is available with a 0 to 10 volt or PWM variable speed control. The EC Plus motor is not available with variable speed control. The EXI 50 motor, the same as the economy, it's not available with speed control in global voltage format, but if you purchase the motor in low voltage DC format, once again that is available with 0 to 10 volt or PWM speed control. The EC Axial fans, these are the axial fans that run from 60 millimeter up to 172 millimeter. The 120 millimeter and the 172 millimeter versions of those fans are available. We can supply those with a variable speed option, once again 0 to 10 volt analog or PWM speed control. So I trust that's answered that question. I think probably at that point we're probably out of time. So all that is left is once again for me to say thank you very much for making your time available for this webinar. We do appreciate the interest in our company and our products, and please reach out to us if there's anything else we can assist you with. We'd be very happy to do that.